Hello, it's Brian Morrow with EE490, and my project was based on a coal-fired power plant, or any power plant actually, that involves the generation of steam. And what we've got here is a motor controller for your boiler feed pump, which feeds water into your drum and keeps the drum level at the correct level in order to produce steam and keep everything safe. So we got the feed pump that feeds in. We've got a case structure here on the default case. What we got is a multiplier that takes this value here, predetermined multiplier that gives an amperage value, which the amperage value is being monitored, and if that gets out of range, I've got a set point of 35 amps, then you'll get an alarm on the front panel. We've also got a feed pump level with a predetermined calculation in order to give us the drum level, which the drum level is also being monitored for high and low levels. And from there, we got an RPM with a predetermined level, which it's being monitored, and it also has actually, it has no kickouts on the RPM level. The amps will take you out, and the high and low levels will take you out. From there, we go through each one of our cases. I utilize a case structure to do this. So I've got 3 cases here with some verbiage here to explain what each one of these are doing. Okay, so once we get through the process, we come over here. We've got our indicators that are monitoring on our front panel, giving us a value on our front panel. We also integrated everything in to give us a feed pump ramp status, which is monitored by a waveform graph. Also, what is very important when you're bringing a unit online is the generator, and the generator, what I think makes this better, this program better than some of the ones I've worked with in real life, is I have utilized a local variable and put it into my generator loop, where my generator is seeing what my drum is doing. And the reason why I've got that going on, and it's going to trip the generator, and it's going to give you a trip alarm if this goes high on a high level. And the reason why it's going to do that is because if you get a high level in your drum, what's going to happen is you're going to you subject yourself to water induction in your turbine side, and that can lead to millions and millions of dollars worth damage. For the interface, we have our controller here, and then we have all the alarms we need to be looking at. We've got a status, our ramp feed status here. We've got our RPMs. We've got our feed pump amps. Got our alarms that are going to come in and alarm us. Got our drum level. And everything is redundant. If you can tell in these shots here, everything is redundant. You got feed pump amps. You got the gauge. If the gauge goes out, you've got a digital readout on. You got 3 more digital readouts, or 2 more digital readouts, and an alarm. Well, actually, a digital readout and 2 alarms. So if any of that thing is all redundant, in case something happens out in the field, because it's a very important process in a power plant. You've also got emergency stops on your feed pump and on your generator. And just to run this and show some alarm settings and things, I've got predetermined settings in there. So right now everything is okay. Now if I increase my feed pump status here, which is in return going to put more water in my drum's going to go up. It's actually giving me a high level alarm here. And then actually, let me click it and make this bigger where we can see this. On that in particular there, I'd went so far as to trip the turbine. So let's see if we can't get, all right, so we're back in there now. We're getting high alarms on our drum level. Our turbine's okay, but this is alerting the operator, hey, you've got to do something, or you're going to get in a situation where you're going to end up tripping your turbine. And now we can go back, make system everything okay here. Alright, so now everything's okay. We got RPMs down here. We're running 200 RPMs, running, it looks like 8 amps. Everything's good. Now, if we get a high level, of course, in automatic, what's going to happen is our feed pump is going to back off. So when our feed pump backs off, if it backs off too far, we're going to get a low level. We got an indication here. Feed pump the feed pump's not pumping. It's pumped all the way, and RPM's back down. It's trying to clear this high level alarm is what's going on. Now then, if that comes into a predetermined time period, then what's going to happen is you're going to trip your turbine on low, and that's just going to be because it's going to see over here on a 20-second delay. Your drum, the operator's not doing anything to bring it back, or you got a problem that you can't bring it back, and so what's going to happen is it's going to trip your turbine. And that is about all I got. Appreciate your time. Thanks a lot.